Well, limits of vector-valued functions behave pretty much like you would expect them to. If r is a vector-valued function, call it f of ti plus g of tj plus h of tk, then the limit as t goes to some number a of r of t is the limit as t goes to a of each of the component functions as t goes to a. So you'd sort of expect that. Provided, of course, they all have limits as t approaches a. So if you drop this off, this last part, then you have the whole thing in r squared. This is in r cubed. So the fact that a vector approaches a limiting vector t as t approaches a can be said by the following symbols. The length of the vector r of t minus the limiting vector L approaches 0. Think of what that's saying. In other words, the length of the difference of these two vectors, and if you think about it in component form, if the length of that's approaching 0, then each of the components is approaching the limiting vector L as t approaches a. And so what does it mean if a vector-valued function is continuous? A vector-valued function is continuous at a point given by t equals a, or at t equals a if you want to say it that way. If that limit vector exists as t approaches a, and that limit vector is r of a, because I mean that limit could exist but might not be the vector-valued function evaluated at a, but if it is, then we would definitely say that's a continuous vector-valued function. That means each of the component functions must be continuous at t equals a. So let's look at one that's weird. Determine the intervals where this vector-valued function is continuous. Well, we've got really three functions to look at: cosine, tangent, and logarithm, ln, right? ln of t. Well, cosine is continuous everywhere, no worries, right? Tangent is continuous except, how would I say this, except at odd multiples of pi over 2. So we'd have to kick those out. And ln is continuous for t positive. That's not even defined for t negative. So what would we say? We would say it's continuous on the interval from 0 to pi over 2, open interval, because 0 is no good for ln, and pi over 2 is no good for tangent. And pi over 2 plus n pi to pi over 2 plus n plus 1 pi. In other words, we're taking an odd multiple. You know, if this is like 2 pi, for instance, and this is going to be 5 pi over 2, so it's going to be an odd multiple of pi over 2 to the next odd multiple of pi over 2 for n starting at 0, because pi over 2 counts as pi over 2 to 3 pi over 2 if we started at 0. So that's a little tricky, but I hope it's not too hard to understand.